Elements are the same type of atom, and compounds are two different types of atoms merged together. These are both pure substances. Mixtures are when you have either elements that are mixed together, like you might see here, a bunch of different atoms mixed together of different types of elements, or up here you see different compounds mixed together. So if we take a look, this one would definitely be compounds, because it's not one type of element or one type of atom. And it would be a mixture because this and this are not the same. Over here, all of these are compounds, but when we look at them, they are all the same. There's not a mixture here. This would be a pure substance of only compounds. Down here, let's check out D. If we take a look at D, all of these are the same type of atom. These spheres right here are showing the same type of atom. So that's going to be a pure substance, and it is going to be of elements. Anybody know what state of matter that might be in? I'll open up the chat so that you can type it if you want. That's true. It is a solid. Good. Nice, Natalie. It is a solid. What state of matter do you think this guy is? Gas, definitely. The particles themselves are very far apart compared to the size of them. So if we take a look down here, is this a pure substance or a mixture? Good. A bunch of people are typing pure substance. They are correct. So that is a pure substance. And is it an element or compound? Well, this right here is the same atom as this, is the same atom as this, atom, atom, atom. All of these are the same atom type. So that is only elements. Even though they're connected, it's still the same type of atom, so it's considered an element. Right here, if we take a look, I don't see anything different. So it looks like this is a pure substance. And instead of being of elements, though, it is of compounds. Same with this one right here, pure substance of compounds. The last one here, all of these are the same atom again, so that is a pure substance of elements only. So I don't see any mixtures amongst these. What's the state of matter here? And again, you can say it or you can type it. Good, that is a gas. Good, that's a gas. Nima? How about this one? Very good, that is a liquid. The particles are close together, but not so much that they're rigid. This one again? Gas is correct. And last but not least, D. Solid. That is a solid. Good, Zelaya. Good, good. On that worksheet also, I wanted to make sure that we touched that mixtures can be physically separated. Compounds, you need some type of chemical separation. If you have sodium chloride, for example, you may have to run electricity through that. But mixtures can be physically separated. So if we take a look here, we have a mixture of sand and salt and water. If we have all of these in here, we could pour this through a filtration device. Since water dissolves salt, but not sand, the water and salt would go down through here. Our sand is not soluble, it doesn't dissolve. Our beaches would look way different than that. So the sand is stuck up here. Now, many of you probably have filtration systems at home, maybe in your refrigerator or for water, drinking water, stuff like that. So that's filtration. This process over here is if you want the water to become pure now. So we have the salt and water here. We're going to use a process to, basically it's called desalinization, or more appropriately, distillation. We're going to heat up the water so that it boils off over here. Water boils at 100 degrees Celsius. Salt melts at 800 degrees Celsius. So we're not in any worry of this salt getting from here to over here if we're only getting this up to 100. So that would make pure water here, and the salt eventually would be left behind here. That is called distillation. So I think that's enough review to bring us up to drawing atoms. So you should have went through the notes section yesterday and learned the parts of the atoms. You have the nucleus and the electron cloud. The three particles that make up the atom are the proton, which gives it its identity, the neutron, which stabilizes it. For example, on the periodic table, you can see that zinc has 30 for its atomic number, so that means it has 30 protons. That's its identifier. No other atom has 30 protons except for zinc. One proton, it's hydrogen. 99.9% of all of the elements in the universe are hydrogen. Think about our solar system alone. How big is the sun compared to everything else? Huge. And it's basically this ball of hydrogen that is fusing hydrogen into helium. That's how you can make helium, through the process of fusion. Well, if there's enough energy, you can actually make, for example, when some of these stars die, they make the iron that's in your hemoglobin. They make the calcium in your teeth. It takes stars to actually die and collapse and basically form these complex nuclei with lots of protons, for these more advanced elements to exist. Well, 99.9% of the elements out there, it hasn't happened to. So there is a bunch of hydrogen out there. The electron tells us the size, shape, and how it will react, the activity of the element. Yesterday we went through the history of the atomic model. So if you've got that periodic table up, or if you've got it next to you, pull it out and let's take a look. Let's find sulfur on there. And we want to find the atomic number of sulfur because that's how many protons it has. What is the atomic number of sulfur? 16 is correct. Nice. It's right here. 16. Some of these are hard for you can see tungsten, for example, W. At one point, you'll want to memorize some of these because you'll be faster with your homework. Otherwise, you'll spend so much time looking around the periodic table that you won't. You'll spend 15 minutes alone on an assignment looking around the periodic table. Radon is Rn, so that little number right there tells us how many protons it has. 86. Good. Moving on, you'll need this format of drawing or writing out the atomic symbol for tomorrow's laboratory. So basically you have the atomic symbol here, the mass number up here, and the atomic number down here. So the atomic symbol for oxygen, does anybody have that memorized? Oh, it's an easy one. Nice. Yeah. It is O. So the 18 here refers to the mass number of this particular isotope. It is oxygen 18. So that 18 goes on the top. We find the atomic number from the periodic table, which is 8. To find the number of neutrons, we take 18 minus that 8. This is the mass number, so that's the number of protons plus neutrons. 18 minus 8 gives us 10 neutrons. All of that information is going to be needed to draw these atoms. And you were to stop here, but you're going to continue here today after we draw a few of these atoms. You're going to continue down through ions. You won't be able to do Rutherford's gold foil experiment, but tomorrow we will be doing this identifying atoms and ions. That's the laboratory you're doing for tomorrow. So after we get done here drawing, you're only to go down to here. So not too much. Let's draw some of these guys. You can see that we drew some last period. Let's start off easy with hydrogen 1. So the symbol for hydrogen is H. The The mass number is 1, and hydrogen has 1 proton. So to draw this, I know in your 6th grade, 7th grade, 8th grade, you guys like drew actual dots. It was probably just so your teacher could have a break while you sit there and drew a bunch of dots. We don't do that here. We actually have you draw the nucleus, and then we're going to write the information in here. It's a lot faster, plus we probably deal with bigger atoms than you did back then. So we have 1 proton, and 1 minus 1 is 0, so 0 neutrons. For the protons, we use a P+. For the neutrons, we use an N and the null symbol, or just a O, meaning no charge. Protons have 1 charge, 1 positive. Outside that nucleus, we have the electron cloud region. The first energy level in the electron cloud region can hold 2 electrons, if you recall. Again, they probably had you draw like little zeros with negatives or something like that. Nope, we don't do that. We just write 1e negative. Even though it can hold 2, we don't need to hold 2. We just need to hold 1. The number of protons and electrons is equal for atoms. Today you're going to find out ions are a little bit different, but for now, protons and electrons equal for atoms. Let's ramp it up. Let's draw this chlorine. So it's chlorine 36. The symbol for chlorine is Cl. We put that 36 up there because that's the mass number. That's the mass of the nucleus. Protons plus neutrons together. The atomic number for chlorine is 17. So that means when we draw our nucleus here, it's going to be a little bit bigger. We have 17 P positives. Anybody got the number of neutrons? Am I going to have to ask the watch? (36 minus 17).
The answer is 19.
Good. 19. Siri gets class participation points today. 19 neutrons. Now this is where it gets a little bit different. We have 17 protons, so we are going to have several levels out here. The first one, again, can only hold 2. Oh, look at that. Natalie got it, too. Nice, Natalie. So 2 electrons first. Second principal energy level can hold 8 electrons. So that gets us up to 8 plus 2, which is 10. For now, we're going to say the third one can hold 8 as well. That'll change in our future, but for now, 8. We don't actually need all 8. All we need is 7. 2 plus 8 is 10, plus 7 is 17. Remember that the nucleus has a positive 17 charge, and around that nucleus is a negative 17 charge. So this atom is neutral. After you get into ions, you're more than welcome to go through and draw the rest of these. I am putting this Zoom that we've done today up there on the calendar so that you can go back and watch this, or you can do a screen snapshot. We found out today that if you want to do a screen snapshot, let me show you the buttons to use. This way you can take a picture of the screen pretty quickly. So basically you would hold the control button, which is down here, and you see this little crazy button right here? Looks like a screen plus 2 dashes. If you click that, it will take a picture of the screen, and it'll save it. Now, if you only want a certain section of the screen, you can hit the Control and Shift, and then that little button. And then it'll let you select out a portion of the screen that you want. So if you want to try that real quick on this exercise, you're more than welcome to. I know that we didn't do sodium or potassium, but if you want to work on that separate, this way you'll have the answers for those.